this one, we notice that sine of 2 theta, we have parentheses there, so that requires a chain rule. Moreover, we notice that we have a variable expression over a variable expression, so we would need to use the quotient rule. So we could sit there and we could go through the top function is sine of 2 theta, the bottom function is cosine theta. Top function would be cosine of 2 theta times 2, which we would write as 2 cosine 2 theta. And then bottom function is negative sine theta. Okay, now I've got news for you. All of this work here after you plug into the quotient rule is completely unnecessary, because if you simplify first using a trig identity, you're going to see that this is a very simplistic question to differentiate. So I want you to know this trig identity. This is our double angle trig identity that says that sine of 2 theta is equal to 2 sine theta cosine theta. This was actually one of my favorite calculus teachers. Her favorite identity was this. So I always think about her, and it's a wonderful, wonderful, wonderful identity because it really allows us to simplify things and not do as much work. So if you look at this particular question here, where you have sine of 2 theta over cosine theta, when you see that double angle, you could say, oh, that is the same thing as 2 sine theta cosine theta over cosine theta. And then you'll see very nicely the cosine thetas cancel. So really what you're trying to differentiate is 2 sine theta. And as we know, 2 sine theta is very simplistic to differentiate. We just get 2 cosine theta. So the lesson I want you to learn from this question is to simplify first, and I also want you to refresh on this identity and know this identity for your test and remaining work, because it could potentially really save you as far as the amount of work that you have to do.